So hello and welcome back to our lecture series on resistors. So in the previous parts, we looked at resistor connected in series, and in this particular video, we are going to be talking about resistors connected in parallel. All right. So if you missed that previous part, kindly check the playlist on engineering, in electrical engineering. You'll find the links to those videos there. So, but now let's talk about resistors in parallel. So now let's define what that is saying. So for resistors connected in parallel, so if you have to define it, says resistors are connected in parallel when they are connected side by side. Exactly. So I'm going to give a drawing to represent that when they are connected side by side. Also, for parallel connection, the potential difference is the same across the resistor, but the current is different. So now let's draw a diagram of what that looks like. So it says for this now it's connected by side. So now we are going to be having, so this is one resistor and this is another resistor. So for this now, so this is how it looks like. So this is the first resistor and this is the second resistor. So let me just put that inside. So this is R1 and this is R2. Are we good? All right. So let's analyze this. So you can see the diagram. So resistors are connected in parallel when they are connected side by side. Now, just like we have in this second line, what it's saying is, it says for parallel connection, the potential difference is same across the resistor. So that means here the value of V, the voltage here for the R1 is also the same voltage we're having here. Exactly. Also from across the terminal, so from here to the end of the other terminal is the same voltage. Exactly, that is flowing. So if the voltage is flowing through it, it's still the same thing. The one that would come here is the same voltage that will flow through here. So that's what that is saying. However, we can see that it says that what the current is different. So if the current is coming from this direction now, if the current is flowing in this direction, the current here is I. Exactly, that's the total current. So once it gets here, it splits up. So one is going to go towards this direction, another will go towards this direction. So now let's say the one that is going towards the upper direction, let's call it I1, and then this one is I2. Very good. So this is the diagram explaining resistor connected in parallel. Very good. All right. So with this now, we can use it to calculate the equivalent or the total resistance of these two resistors, this resistor R1 and R2. Exactly. So how do we know the equivalent? How do we know the total resistance of those two resistors? So in doing that, now we are also going to make reference to Ohm's law. Now here we said this is I, which is the current that is coming. So once it gets to this junction, they both split, isn't it? So that means we can say that I is equals to I1 plus I2. Are we good? However, from Ohm's law, we know that V is equals to IR. Are we good? So that means if we make I the subject formula, we are going to be having I is equals to V over R. So we can now use this to come over to this place. Now if you have to calculate the current at this point here, so that at that point, let's call this point O. So that means the current there, I, is just going to be V over R. Exactly. Where this R is the equivalent or the total resistance. Exactly. So let me change my color there. So where this is the R total, or you can call it the R equivalent, the equivalent resistance, and then V is the voltage. And remember that we said for parallel, the voltage is the same thing. Exactly, the voltage is the same across. All right. So now if we should come over to this, where we're having I1, exactly. So that means our I1, So that means our I1 will then be V over R1. Let's go back to it. So you can see that means the current that is flowing through this R1 resistor is just V. Remember we said the value of V here is the same value at R2. So that will be V over R1. That's how we got it. And then we can also say for I2, so then for I2 will also be V over R2. Exactly. So we are having the same voltage across it. It's just that the resistance, the value of the resistance are different on the resistor. Alright, so now let's come back here. So since we've established it that here that I is I1 plus I2, I've explained that earlier. This is I, this is the total current. Once it gets here, that is when they split. One is going up to serve R1, the other one is coming towards this direction to serve R2. So that means we have I1 is equals to, I is equals to I1 plus I2. So if we should do the same thing with all of these values here, that means we are going to be having V over R, that is this one, is equals to V over R1, which is this, plus V over R2, which is for this. Alright, so you see that the value of V is the same thing across. So if we have V over R is equals to V, so let's just put that into brackets, 1 over R1 plus 1 over R2. Okay. So to cancel out this V, since they are both the same thing, so we can just say that let's multiply both sides. So let's multiply both sides by 1 over V. Exactly. So just to make sure that everything is mathematically correct. Okay, so if we should do that, we are going to be having V over R times 1 over V equals to 1 over V times V into brackets 1 over R1 plus 1 over R2. Okay, so this can cancel out this, and then we'll be left with 1 over R is equals to 1 over R1 plus 1 over R2. Okay, so if we make R the subject formula, we are going to be having R is equals to, so you can just go ahead and then look for the LCM. So the LCM here is just R1 plus, R1, R2. So I wanted to skip it, but let me just do it. So if you should do it, R1, R2 divided by R1 will be left with R2. So R2 times 1, that will be R2. So if we have R1, R2 divided by R2, that will be R1 multiplied by R1. So that will be plus R1. Okay. So let's just do everything once, so I don't skip any step. Alright, so that means we are having 1 over R is equals to R1 plus R2. Let me just rearrange that. R1 plus R2 over R1, R2. Alright, so we can just decide to say you want to cross multiply, or you can just turn it around since this is 1 over R. So that means we are going to be having R is equals to R1, R2 over R1 plus R2. And what we are having here is the value of the equivalent resistance for when resistors are connected in parallel. So like I said, this R that we are having here is the same thing as RT. Some material might write as R with subscript T or R with subscript EQ. Exactly. So now what I want to give you as an assignment is for you to look for the value of the equivalent resistance when you have 3 resistors that are connected in parallel. So the circuit will look like this. Exactly. So do make sure you try it. So the circuit will look like this. This will be the terminal here. So this is your R1, R2, R3. And then, so this will be your I. Exactly. So that means there will be a particular, so at this point, this will be your I1. So here, this will be your I2. And then towards this direction, this will be your I3. And then don't forget the voltage will be the same thing. So the voltage drop from here to here it will still be V. So what that means is that the voltage here is V, it's also V, and it's also V. So use the idea here that we have used in this first example to get the answer that you are going to get your Req, your R equivalent, when we are having 3 resistors. But to make it easier for you, let me just give you what the answer will be. So I want you to do it and see if you're going to get the same answer. Just like I said when I was doing that of series, most questions will not ask you to look for the equivalent of resistance of a resistor for 2 resistors. They always give 3, 4 like that, because it's kind of like a little, I don't want to use the word complicated exactly, but if you understand the process, you'll be fine. So that's why I want you to take that as an assignment. So you're going to be having something like this: R1, R2 plus R1, R3 plus R2, R3 over R1 plus R2 plus R3. Exactly. So now for the one at the numerator, at this top here, you can have it in, you can arrange it in different ways. Your R1, R3 can decide to come first, followed by your R2, R3. Exactly. So depending on how you are doing your calculation. But once you have something like this, just know that this is what you are going to have. So let me know in the comment section if you arrive at this answer. Exactly. So that is it on resistors in series and parallel. So now let me talk briefly about some significant difference between resistors in series and resistors in parallel. I mentioned it in the course of the video, but let me just mention it specifically. So let me just give this 2. So you can decide to expand it to more than 2, or just research on it. So the first one says that for that of series, the same current flows through it, flow through the resistor. Exactly, I've explained that when I was talking about series. Then on the side of parallel is the voltage. The voltage across each of those resistors, when they're in parallel, they are the same thing. But if they are in series, the voltage differs. Exactly, so don't mix them up. Now for the equivalent resistance of the resistors collected in series is just the addition of each individual resistors. Exactly, just add them up straight up, you get the equivalent. Then for that of parallel, it's just 1 over the equivalent plus 1 over R1 plus 1 over R2, like that. Exactly. So that's it, guys. So I hope you find value in this. If you do, please give it a thumbs up. And please, if you are yet to subscribe, please show some love. Kindly click on that subscribe button if you know you have gained a lot from it. And if you have any question, just let me know. So in the next part of this video, we are going to be looking at the current divider rule and voltage divider rule. So with that, guys, I'll see you all in that next video.